The perfect arc of the northern crown is a shining wedding wreath thrown into the sky by the god Dionysus. According to legend, he saved the abandoned Ariadne, turning the precious stones of her crown into eternal stars. But today this crown holds scientific anomalies. For example, a star that suddenly disappears in clouds of soot. And right now, astronomers are waiting here for the historic explosion of a rare nova that will illuminate the sky.
Welcome. Today we are diving deep into Corona Borealis, the Northern Crown. Now this is a constellation with a really fascinating double life. On one hand, it's a star in ancient myths, but on the other, it's a critical, real-world laboratory for astronomers. We're going to explore both sides of its incredible story.
So, what makes Corona Borealis so special? Well, just look at it. It's a nearly perfect semicircle of stars that has captivated people for thousands of years. But this beautiful celestial crown is also, believe it or not, a hotbed of some of the most extreme cosmic activity out there, making it an absolutely key area for scientific study today. So, here's our roadmap. We'll start by just appreciating its form, then we'll get into the nitty-gritty of its astronomical data. After that, we'll meet its most remarkable stars, explore its rich history in mythology, and then finally, I'll give you a practical guide on how to go out and find it for yourself.
All right, let's start with the basics. In this first section, we're just going to get to know the Northern Crown, not as some random collection of stars, but as the beautiful and really recognizable pattern that it is in our night sky. Okay, so now let's move from what it looks like to where it lives. To really understand Corona Borealis, we've got to pinpoint its exact place in the cosmos, how big it is, where to find it. This foundational data is the key to everything else we're going to discuss.
So the constellation itself covers an area of 179 square degrees on the celestial sphere. Now that number by itself might not mean a whole lot, but it gives us a precise measurement of its footprint in the sky, which helps put things into perspective.
And where does that 179 degrees put it in the grand scheme of things? Well, it ranks 73rd in size out of all 88 modern constellations. So the takeaway here is that it's actually one of the smaller ones. But its incredibly distinctive shape makes it punch way above its weight. And within that area, on a good clear night, there are about 20 stars bright enough to be seen with the naked eye. And it's these 20 or so stars that come together to create that famous and unforgettable crown shape.
You know, one of the really great things about Corona Borealis is just how many people on Earth can see it. If you're anywhere from the North Pole all the way down to about 50 degrees south latitude, you can see the entire constellation. That covers pretty much every major populated area on the planet. It's only when you get to the very deep south that it finally dips below the horizon.
And finding it in the night sky is actually pretty simple. You'll want to look for the prominent constellations of Boötes and Hercules. It's tucked right there between them. But here's an even easier way. Find the two brilliant stars Arcturus and Vega. If you draw an imaginary line between them, Corona Borealis sits almost exactly in the middle. For those of us in the northern hemisphere, your best bet for viewing is going to be in May and June.
Okay, now we get to the really exciting part, the astrophysics. This small patch of sky is home to some truly bizarre and remarkable stars. Stars that really challenge our fundamental understanding of stellar physics. It's like a natural laboratory, just hanging there in space. The brightest star, the jewel in the crown, is Gemma, also known as Alphecca. Its traditional Arabic name, Alphecca, means the broken one, which is a beautiful reference to the constellation's broken circle shape. But Gemma isn't one star. It's actually two stars locked in a tight orbital dance. From our perspective here on Earth, they periodically pass in front of each other, causing the system to dim and brighten. And what's really exciting to astronomers is that it's surrounded by a huge disk of dust, the potential birthplace for brand new planets.
Next up, we have one of the weirdest stars you will ever encounter, our Corona Borealis. This is the prototype of a very strange class of star, often called an inverse nova. You know, a normal nova is a star that suddenly gets much, much brighter. Well, this one does the exact opposite. It will suddenly and completely unpredictably just fade away to almost nothing.
So how does this happen? The mechanism is just wild. Most of the time, the star is sitting there at a stable brightness, just visible to the naked eye. But then, without any warning, it basically exhales. It puffs out a huge cloud of carbon gas from its atmosphere. As this gas cloud drifts away, it cools and condenses into solid particles. Think of it as a giant cloud of soot. This soot cloud then blocks the star's light from reaching us, making it seem to just disappear.
Then over weeks or months, the star's own light pressure literally blows the soot cloud away, and it pops back into view at its normal brightness. It's incredible. And if one bizarre star wasn't enough, we have another, T Coronae Borealis, famously nicknamed the Blaze Star. This is an extremely rare object known as a recurrent nova, and what that means is it doesn't just explode once, it does it over and over and over again on a cycle that we can actually predict.
And we have a pretty good record of its eruptions. We saw major ones back in 1866 and again in 1946. That gives it a rough cycle of about 80 years. And if you do the math, well, that means the next one is due any day now. Astronomers all over the world are watching this star, expecting it to erupt sometime between now and 2026.
And the scale of these eruptions is just mind-boggling. Normally, T Coronae Borealis is so faint you'd need a decent telescope to even have a chance of spotting it. But when it goes off, its brightness increases by a factor of almost 1,600. It goes from invisible to being as bright as the North Star, becoming, for a short time, the brightest object in the entire constellation. It absolutely lives up to that Blaze Star nickname.
All right, we've gone deep into the astrophysics. Now let's switch gears and look at the human element, the stories. We're going to explore the rich history and mythology that people throughout the ages have woven around this unique shape in the sky.
And what's amazing is how different cultures saw totally different things. For instance, Arab desert nomads saw that broken circle not as a crown, but as Al-Fakka, the broken bowl of a beggar. Centuries later, in a completely different context, there was an attempt in the 1730s during the Baroque era to Christianize the sky, and they tried to rename it the Crown of Fermion. It's a perfect illustration of how the same pattern of stars can spark wildly different ideas, all depending on the cultural lens you're looking through.
But the most famous and enduring story, by far, is the Greek myth of Ariadne. Her story begins with an act of both love and cleverness. When the hero Theseus came to Crete to face the monstrous Minotaur, it was Ariadne, the king's own daughter, who gave him the tools he needed to survive: a weapon, and even more importantly, a ball of thread to find his way out of the labyrinth.
So after his triumph, Theseus fled Crete, taking Ariadne with him. But on the island of Naxos, he was visited in a dream by the god Dionysus. The god declared that Ariadne was destined for him, a god, not for a mortal hero, and he commanded Theseus to abandon her. Compelled by this divine will, Theseus sailed away, leaving her behind. Ariadne awoke, heartbroken and alone. But then Dionysus himself appeared, not as a dream, but in his full divine glory. To comfort her and to prove his eternal devotion, he took her wedding coronet and hurled it into the heavens. As it soared through the sky, its jewels transformed into stars, forming the constellation we see today, an eternal symbol of salvation after betrayal.
All right, we're at our final section. Let's take everything we've talked about, the science, the myths, and turn it into a practical guide so you can actually go out and see this for yourself.
Finding the crown is easy. Just start with the Big Dipper. Follow the curve of its handle to that bright star, Arc de Rus, arc to Arc de Rus. From there, just look a little bit to the east or to your left, and you'll spot that distinct U shape of the crown. The brightest star, Alphecca, is right there in the middle. And most importantly, keep an eye on that spot. You have a chance to witness a truly historic astronomical event with T Corona Borealis.
And that brings us to the end. We've seen Corona Borealis as a beautiful shape in the sky, a laboratory for cutting-edge science, and a legendary symbol. But now the story moves from our screen to the night sky itself. The next great explosion of T Corona Borealis isn't a matter of if, it's a matter of when. So the final question is really for you. Will you be there to witness this celestial drama?
Thank you, friends. Strive for understanding and become wiser. See you soon.